Hey guys, welcome to the Object-Oriented Programming Recitation. Let me quickly run you through the notebook. First thing to note is what are classes and objects, which are basically the basis of why we call it an object-oriented programming. Classes are nothing but a blueprint of an object, and objects are nothing but the instance of a class. These are textbook definitions, so what do they actually mean? An example of a class would be a dog. uh, there might be breed A and breed B, which are objects of that class. Well, methods, what are methods? Methods are basically the functions that we define inside a class, which are common to the objects belonging to that class. I will run you through more examples as we proceed through the notebook. Let's come to constructors as well and just define it. Constructors are nothing but they help in initializing new objects. So now that we know the very basic definitions, let's dive into the notebook so that we actually get to understand. So as you can see here that whenever we are defining the class, for example, you can see the class car here being defined, you can see two methods that are being defined inside the class car, which is the def init and the def accelerate. Now, you will note that the very first block that we have defined has a lot of arguments called self dot model, self dot passengers, and so on. And even in the function call where the parameters are being passed, you have the self argument. So, what is the self argument? The self argument, you must remember, has to be defined whenever we are trying to refer to the specific instance of that object that it's being operated upon. So, for example, in this class car, if we have two objects being defined of the type car, then if you can see, it's BMW, Ferrari, Ford. So these are three objects which are under the subheading of the class called car. The def init is basically called the constructor. What is a constructor? Like I mentioned, it is used for initializing the class. What does it initialize? It initializes things called class attributes or instance attributes. In this case, def init will have instance attributes. Instance attributes are nothing but the properties or that are defined inside a method. So therefore, self.model, self.passenger, self.color, self.speed are all instance attributes. But if I were to define an attribute which is outside a method, then that would be common to all the objects of a class. That wouldn't be individual to the different instances that are defined in a class. For example, BMW would have the same mileage as Ferrari or Ford, but BMW's model would be different from that of Ferrari's and Ford, if that makes sense. Okay. And the init method specifically is basically just known as the initializer or the constructor, which basically makes sure that all the attributes that are mentioned are validly instantiated. So basically, we have gone through this whole portion. As you have seen, I have passed parameters separately for BMW, Ford, Ferrari, and accordingly, I have printed out the different attributes, and I have also called the function accelerate, where basically the speed for that particular car has been printed out. Okay. Let's move on to the very interesting topic of inheritance, which is one of the most important things in object-oriented programming. Well, inheritance is basically when we have one class inheriting the other class. The class which is getting inherited is called the parent class. The class which is inheriting the parent class is called the child class. So that's a very basic definition. One of the main uses of inheritance is reusability. Now, what do we mean by that? We can just run through the notebook and understand. So here we have the parent class called person. We have the constructor defined. We have a method called printName defined. Inside the constructor, we have instance attributes, first name, last name. We are passing parameters John and Doe into the class when we define X as the object of person. And what we are doing is here in the print statement, we are printing out the first name and the last name. That is, we are printing out the instance attributes. Then we create what is known as a child class. So as you can see in the class definition, when I'm defining class student, I am passing person into the class definition. That means that everything that belong to class person becomes a part of class student. So now if I access x dot print name inside class student by passing Mike and Olson, then it will go into the constructor for class person and use the method of class person and will print out X. So that's what inheritance does basically. Now, we may want to separately define the init method. We do not want to use the constructor that was used in class person. In that case, we can define a separate instructor for constructor, sorry, for class student. We can overwrite, if we don't want to use a separate constructor for student, we can skip that. Or if we want to use, or we want to make sure that it uses its parents structure, then we can just go define a constructor. Inside that, we can do like the parents dot constructor function, and that will make sure that it inherits its parents init function. One important thing that you'll notice in many object-oriented programming codes is something called a super function. What does a super function do? It will make sure that when you do like, so student is basically the child class of person, which is the parent class. Inside a student's constructor, if you do super dot init, it will automatically inherit the constructor. So basically, you don't have to use the parent's name. It will automatically inherit its methods and its properties. Okay. Now you can add different kinds of parameters inside the constructor would have been already defined in parent. You can add new attributes to it. So there comes the feature of reusability. So here we had defined first name, last name. Now inside students in it, we can also like add graduation year. We can also pass, therefore, since we have like added graduation year, we can pass that parameter and we can print it out and see. We can also, apart from the existing methods that the child has got from its parent, we can also uh, add in new kinds of methods which will become a part of the class student along with the previous method it had inherited from its parent's class person. So in this case, we have uh, a function called def welcome, where basically we are printing out like a statement. So we can do these kinds of features as well. Okay. Now we're going to talk about, so this we talked about was nothing but single inheritance, since there was only one child from the sub branch of person. Okay, moving on. Now we're going to talk about multiple inheritance, in which now uh, we are basically taking one child and taking two parents. So we are inheriting from two parents. That would be multiple inheritance, a single child from two parents. A simple example would be we have a class mother, we have a class father, and we have a class son, which inherits both from mother and from father. So class son will have access to both of the functions, def mother and def father, which are defined in those parent classes respectively, and also to their class attributes, which son will have access to. So you can quickly run the code and check it out. It's very simple. Okay, moving on to multi-level inheritance. What is multi-level inheritance? Multi-level inheritance is, for example, between grandfather and child. So you have a parent class, you have a class inheriting the parent class, which is known as the child class, and a newer child class, which inherits the previous child class. So grandchild class will not only have access to child class, but will have access to the base class as well. So a very simple thing that you can note here is in base class, we have defined a method called getName. In child class, we have defined a method called getAge in addition to it having getName already. Grandchild has a new method called getAddress. So grandchild, since it inherits child and base, will have access to all the methods that have been defined so far. So get name, get age, and get address. And we can just simply print it out like you see here, CMU student 20 Pittsburgh. Okay. Now, moving on to hierarchical inheritance, that is when that more than one derived classes are created from a single base. And this type of inheritance is called hierarchical inheritance. So basically, we have a parent base class and we have two children from that same base class. So you can just simply run the code and check this out. Okay. And hybrid inheritance, which is one of the last categories we're going to discuss, which is it consists of multiple kinds of inheritance. It can consist of multi-level inheritance, multiple inheritance, single inheritance, all kinds of the mixtures of inheritance we have called towards so far. So if you can quickly identify that student one school would be and student two school would be the very last inheritance that we had talked about, which is hierarchical inheritance. Student three comes from student one and student school, which would also be an hierarchical inheritance, but it would be a multi-level inheritance also because student one had inherited from school. So you can just run this quickly and have a look. There are a few interesting facts about inheritance which you can brush through. Method resolution order, where since you are doing multiple inheritances, you are basically overwriting many uh, functions. So basically, when class 1 is defined, class 2, class 3, and class 4 are defined, and you're using hybrid inheritance structure, then basically we see in what order would the functions be called if we are overwriting the same functions in each of the classes as we are inheriting. Similarly, there is an interesting fact about super functions with multi-level inheritance. And when the constructor is being overwritten, when we are inheriting from one class to another, we want to see that when we call the last class, so here GFG would, you can call it as the grandchild like we had seen in hierarchical inheritance. If we overwrite this and we call an object of the grandchild class, which is GFG3 here, then what is the order in which the constructor gets called? So super, what it makes sure is that you are calling the constructor for the immediate parent. So first it calls class 3, then class 2, and then class 1. And super can not only access the constructor, but any other method. So if we have like something called a sub GFG, then super can even override that particular function, which had been defined in class 1. So have a look at this. And there are some good to knows, which again you will come across a lot in object-oriented code is class method versus static method. So I have shared a link here, so please have a look at the link. This is extremely helpful. And have a look at Dunder or magic methods, which makes writing formulas in your code very handy. Okay, and coming to the last part of the recitation, there are basically exercises on recursion and on depth first search. Recursion, as you know, is basically when a function calls itself again and again. So you can have a look at the exercises where it's a simple exercise where you have to generate like a Fibonacci sequence. And lastly, the last exercise would be of depth first search with recursion. I hope you guys are familiar with depth first search, where basically we have asked you to do an in order traversal. An in order traversal is basically when you move from root, left, right, and depth first search is basically when you keep traversing till you have visited the node and you make sure that you have reached the leaf node. A leaf node is one which does not have any child. So here D, E, F would be leaf nodes. So till you reach D, E, F, you keep repeating the order till you do root, left, right. So hopefully you have got a brief idea of object-oriented programming and hope you do well for the rest of the semester. Bye guys.